This lesson is for Mrs. Cucci's College Now PreCalculus class. We are on lesson 5.5, circular functions, graphs, and properties. So if you go ahead and get that open, we'll get started. Okay, so by the end of this lesson, you will be able to, given the coordinates of a point on the unit circle, find its reflection across the x-axis, the y-axis, and the origin. You will be able to determine the 6 trig function values for a real number when the coordinates of the point on the unit circle determined by that real number are given. You'll be able to find trig function values for any real number using a calculator. And you'll be able to graph the 6 circular functions and state their properties. Okay, so this is just a reminder from last lesson. We did talk about arc length. The arc length S on a unit circle is the same as the radian measure of the angle theta. We call it a central angle. S can be considered the radian measure of an angle or the measure of an arc length on the unit circle. So we will be using this formula once again, S equals R times theta. S being the arc length, R being the radius, and theta being the angle in radians. Okay, so we have some basic circular functions. For any real number S that determines a point xy on the unit circle, sine of S is your second coordinate, y. Cosine of S is your first coordinate, x. And tangent of S is your second coordinate divided by your first coordinate, or y divided by x. So instead of using xy, we use cosine sine, essentially. Okay, so similarly, cosecant, we're going to be doing 1 over y, or 1 over your second coordinate. Secant of S is going to be 1 over x, or 1 over your first coordinate. And cotangent S is going to be x over y, or your first coordinate divided by your second coordinate. All right, so we do have some rules for reflection, and I do ask that you get these written down on a note card so that you have them memorized. When you're reflecting over the x-axis, you have the point xy. That point, when reflected, becomes x negative y. So you're negating the y coordinate. When we reflect over the y-axis, xy becomes negative xy. And when we're reflecting over the origin, it becomes xy becomes negative x negative y. The following point lies on the unit circle. Find the reflection across the x-axis, the y-axis, and the origin. Okay, so your reflection on the x-axis, if we remember correctly, I'm going to go back here and take a peek. We're going to negate the y-coordinate. So this point becomes 3/5, negative 4/5. When we reflect over the y-axis, we negate the x-coordinate, negative 3/5, 4/5. And when we reflect over the origin, we negate both the x and the y coordinate. And those are your reflections. Okay, so let's take a look at the next one. What was that? The following point lies on the unit circle. Find the reflection across the x-axis, the y-axis, and the origin. So square root of 2 over 2, square root of 2 over 2. So reflection over the x. We know we negate the y. Reflection over the y. We negate the x. And reflection in the origin, we negate both. Okay. Okay. The following point lies on the unit circle. Find the reflection of the x, the y, and the origin. I think that we should probably have this down pat by now. Why don't you just go ahead and do it real quick in your notebooks, and if you have a question in class, ask about it tomorrow. So now let's talk about finding function values. Your goal is to memorize the points on the unit circle for the first quadrant. That has got to be done. Okay? These points allow you to know the function values of any points on the unit circle because those points all come from our reference angle. So the rest of it is simply reflections over the axes. Okay, so we're going to find the function value at pi over 3. Now, pi over 3, we know is the same as 60 degrees. Okay? So, we know at 60 degrees, or pi over 3 radians, which is about here, we have the point 1/2 square root of 3 over 2. Okay, and again, you should have that memorized. Okay? Tangent, we know, is the ratio sine over cosine. So what we can do is we can take those values, and we said tangent is going to be our y-coordinate divided by our x-coordinate, and we simply do the division. Okay? So, tangent of pi over 3 is the square root of 3 over 2 divided by 1/2. Complex fraction, we know we multiply by the reciprocal of the denominator. Those two cancel very nicely for us, and I'm left with the square root of 3. Okay, so let's take a look at our next one. Cosine of 3 pi over 4. All right. So, 3 pi over 4, we know is directly across on the unit circle from 1 pi over 4. Okay? All right? It's directly across. We know the point at pi over 4 is square root of 2 over 2. And since it's a reflection over the y-axis, this point becomes negative radical 2 over 2, radical 2 over 2. Okay? So, cosine is your x-coordinate. So this very simply equals negative radical 2 over 2. Okay? The next one is sine of negative pi over 6. Pi over 6 is going to line up with negative pi over 6, okay? So pi over 6 being 30. Negative pi over 6 is going to be right down here, okay? We know that this point is the square root of 3 over 2, 1/2. Since it's a reflection over the x-axis, we negate our y. Oops, square root of 3 over 2, negative 1/2. Okay. Sine is your positive, or your y-coordinate. So this very simply is going to equal negative 1/2. The next one is cosine of 4 pi over 3. 4 pi over 3 is going to match up with pi over 3, okay, which we know to be 60. 4 pi over 3, if this is 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3 is going to be right down here. Okay, so 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. We're going by intervals of 60. So 4 pi over 3 is in that third quadrant. And this is a reflection over the origin. So this pi over 3, which is 1/2 square root of 3 over 2, since it's reflected in the origin, is going to be negative 1/2 negative square root of 3 over 2. Cosine is your x, so it's going to be negative 1/2. Next one is going to be cotangent at pi. Remember, cotangent is the reciprocal of tangent, so instead of being sine over cosine or y over x, it's going to be x over y. Pi is right here. This is the point negative 1, 0. So x is negative 1, y is 0. This is going to wind up being undefined. I'm going to look at one more. That last one is going to be cosecant of negative 7 pi over 2. Okay. So what we're going to do is we're going to draw our rotation diagram. So our unit circle. Okay. Now, negative direction means I'm going clockwise. Pi over 2 is a quarter of this entire circle. So here's 1 pi over 2, or negative 1 pi over 2, negative 2 pi over 2, negative 3 pi over 2, negative 4 pi over 2, negative 5 pi over 2, negative 6 pi over 2, negative 7 pi over 2. It's going to land right here. This is the point 0, 1. Cosecant we know to be 1 over sine. Okay. Or 1 over our y coordinate. So this is going to be 1 over our y coordinate, which is 1. So cosecant at negative 7 pi over 2 is going to be equal to 1. Okay, find the following function values of the radian measure using your calculator. Round the calculator to 4 decimal places. We're going to do cosine of 2 pi over 5. Now this is simply calculator work, so cosine of 2 pi over 5. What I need you to keep in mind here is this is written in terms of radians. And we know that because we have our pi in here. Okay? So that means that in order to do this, we have to make sure that our calculator is in radians. So what I'm going to do is I'm going to insert a calculator page. And I'm just going to check in this upper right-hand corner. Notice mine says DEG. That means degrees. So I do need to adjust. So I'm going to click on that. I'm going to go to my document settings, and I'm going to change this angle to radians, and then make it default, and OK. So now I can go ahead and simply enter what I had into my calculator, the cosine of 2 pi over 5. And to the nearest 4 decimal places would be 0.3090. Okay, right here. Okay, the next one was tangent of negative 3. And again, this is in radians, so we're just going to simply put that into our calculator. We're already set. Tangent of negative 3. When I hit enter, to the nearest 4 decimal places, we're going to get 0.1425. Sine of 24.9 is the next one. So we're simply inputting it into our calculator. And then we should have negative 0.2306. One last one, secant of pi over 7. We can use our secant key. Go ahead and put your fraction template in. Pi over 7. 1.1099. Okay, so the next section of this is graphing sine and cosine functions. We're actually going to stop this video here and pick up with graphing in the next one. So if you want to just go ahead and save your document and come prepared to class with any questions you might have tomorrow. Thanks, guys.